So let's review 4 important rules when we are making the calculations for enthalpy. The first rule is that when a reaction is reversed, the magnitude will be the same for the delta H, only the sign will be reversed. So if you are moving from the reactants to products like that, and the value is delta H is 73, so the backward from the products to the reactants will be delta H is equal to negative 73, for example. The second rule for calculation of enthalpy is that when the balanced equation is multiplied by an integer, so if I have this fraction and it is multiplied by the integer, the delta H of this equation also has to be multiplied. So if you have the first equation and it's showing that per 1 mole of the reaction, let's say it's NO2 is formed 1 mole and delta H is minus 50 kilojoule. So if you are doubling the equation and making 2 moles of NO2, the delta H also has to be doubled to be negative 100, for example. The change in enthalpy for a given reaction can be calculated from the delta H of the reaction. The standard conditions will be equal to the sum. So this sign is meaning the sum of the delta H of formation. So the sum of the delta H of formation of the products subtracted from the sum of the delta H for all the reactants formation, And the last rule is that the elements in their standard state are not included in this delta H reaction, because if you are making oxygen and then forming it from its forming elements, it's made from oxygen. Oxygen is made from oxygen, and oxygen O2 is its standard state already. So the delta H for formation of this element is equal to 0. I did not change anything. Let's try to have another example. In this equation, I'm trying to find the enthalpy from the standard enthalpy of formation. Enthalpy of the reaction, for example, 4 molecules or 4 moles of ammonia gas has reacted with 7 moles of oxygen gas, form 4 moles of nitrogen gas plus 6 moles of water, liquid form, of course, in the standard state. So I need to find the pathway in which the reactants are broken down into elements in their standard state, which are then used to form the products. So for example, the nitrogen and hydrogen will be forming the ammonia. So if you want to form NH3 for NH3, you are actually making them from nitrogen gas and hydrogen gas in the standard state. So hydrogen and nitrogen gas in the standard state. But take care, if you are making one NH3 only, if you are making only one NH3, you will need just half N2. So you just need half N2. But how many H2 you will need? You are making 3 H's if you are having H2. So you are making 3. Let's break it down again and show it exactly how did I get this. I need to make 1 nitrogen, and I'm making it from N2. I need this to be 1 atom. So this is 1 nitrogen, but I'm making it from nitrogen. Why I'm making it from N2? Because this is the standard state of nitrogen in the atmospheric pressure, in the atmospheric pressure and 25 degrees. It's available as N2 gas, diatomic. So to form this, you have to make it half N2, so it will be 1 atom. Again, I need to make NH3, and the hydrogen here is 3 hydrogens. So if I'm using H2, how many of the H2 molecules I need to make? You need to H2 change it into H3. So to change H2 into H3, you have to multiply it by what? You have to multiply it by 3 over 2. Because when you multiply 3 over 2 by 2, this one will be cancelled and you form 3 hydrogen atoms. So in order to do this, you have, so in order to change from N2 and H2 into NH3, you have to have half of the N2 and 3 over 2 of the H2. Then in this case only you will be forming 1 mole of NH3. And from the given in the question, I will be given that the standard enthalpy for the formation of 1 NH3 moles requires minus 46 kilojoules for every mole. For every mole of the NH3. But since I don't have only 1 NH3, I have 4 NH3. That's why I have to multiply this value by 4. Again, let's have a look. You are forming NH3. To form 1 NH3, it's negative 46, but you need to form 4 NH3. So multiply it by 4, you will get 184. you'll get 180 minus 184 kilojoule per mole. Let's have a look at forming NO2 and forming H2O. From the table and given, I will be given that delta H of formation of N2 requires what? Requires 34 kilojoule per mole. Again, I need this to be multiplied by 4. I'm making it, by the way, from N2, half N2, and I'm making it from 1 mole of oxygen. 1 mole and oxygen and N2. And to form this, you have to multiply it by 4. So by 4 is equal to 136 kilojoules. Again, if you want to form water, you will look at the table and you will see that formation of 1 mole of water only from H2 and O, requires how many? From H2 and O requires minus 286. Again, you are not making 1 water only, you are making 6. So minus 286 multiplied by 6 equal to negative 1716 kilojoule. Again, from the delta H test cycle, I need to find the delta H of reaction is equal to the opposite of this one, these values that you are given here, which is formation of oxygen. This is an element, O2 to O2, this is 0, as we said. This one, we said it's negative 46 multiplied by 4, so negative 184. This one has to be reversed. Why? Because you will work like that. If you want to find this, you have to go from here to here, reverse these values, and then here to here, this value is the same. So it's equal to the delta H1, but it's reversed. So the negative of the delta H1 and added to the delta of H2, the delta of H2. So it is the delta H of formation of the products minus the delta H of the formation of the reactant, the same way we have explained when we said it will be easier if we say products minus reactant. So basically you are saying the delta H2, which is minus 286 multiplied by 6, which is minus 1716. And then when you make minus 1716 and add it to the NO2, we said that it is NO2, we said that it is 136, so plus 136. And all this will be subtracted from delta H1, which we said is 4 multiplied by NH3. We got it is equal to minus 184. So negative 184 is positive. You have to be very, very careful with the sign. Let me show you how the answer will come up. It is 1716 in the negative form plus 136. So already was positive. And then it is minus 184, minus 184, so equal to plus 184, that's equal to minus 1396, minus 316, is equal to minus 3196, minus 1396 kilojoules for the reaction formation of 1 mole of NO2 or 4 moles NO2. It is the formation of 4 moles of NO2 from 4 moles of ammonia and 7 moles of oxygen required 1396 kilojoules. And remember, this is the full value, so it is for the full value of the reaction formation, or the delta H of the delta HR, we call it the delta HR.